This is problem number 10 from section 3.2. In this problem, they say the Department of Transportation's budget for pedestrian and bicycle programs in millions of dollars for selected years is given in the following table. Okay, so we got the years, and then we got the budget, and remember the budget's in millions. Determine a quadratic function b whose vertex is 1994, 170, and whose graph passes through the point 2009, 1200. Write b of x in vertex form. All right, vertex form was from the last section. In vertex form, let's have a little reminder here, is f of x equals a x minus h squared plus k. And the vertex here for that formula is always h comma k. So they're telling us the vertex right here. So they're telling us that this is h and this is k. So we can start writing this out for part A. F of x equals a x minus 1994 squared plus 170. So we almost have a function just by plugging in the vertex. They tell us that the graph passes through this point because they know we don't have a right now, right? We need to find the leading coefficient. So they're basically telling us to use this information in this equation to solve for a. So f of x, and actually they call it b of x. So b as in the budget, right? So we're going to write that as b of x. So b of x stands for basically the millions of dollars, right? So that's going to be the 1200 part, and the 2009 is going to be the x part. So we're going to say 1200 equals a 2009 minus 1994 squared plus 170. We're going to subtract the 170 over. Remember, we're trying to find a. So 1200 minus 170 is 1030 equals 2009 minus 1994, that's 6, that's 15 years. So it's a times 15 squared. 15 squared is 225, so it's 1030 equals a times 225. Divide the 225 over, and 1030 divided by 225 is 4.577 repeating. Now, I think they want us to round this. So we're going to say a equals 4.5777, but I think in this problem they want us to round it. So we're going to say a is probably to the 10th, I'd imagine, so 4.6. Just rounding that number that you get in the calculator. So let's write the equation then. So the equation would be b of x equals 4.6 x minus 1994 squared plus 170. And so that's the answer for part A. Part B then, we take that and we use it to figure out when the budget was 630. So we're going to, again, take b of x, we're going to fill it in with 630 equals 4.6 x minus 1994 squared plus 170. Now they're doing us a favor here because they're giving us an equation that we can actually, that's a quadratic, right? But because they have this x minus 1994 squared, because this is a perfect square in here, we're going to be able to use the square root method. We don't have to use the quadratic equation, factor, anything like that. So they actually made it pretty easy by putting this in vertex form for us to solve this. So we're going to subtract by 170 here to start. And when we subtract by 170, we get 460, I believe. Let's double check it just so we don't make any errors. 460 it is, which is kind of convenient because the next step, we're going to divide by our rounded number, which is 4.6. That kind of worked out nicely. So divide by 4.6. 460 divided by 4.6. Going to give you the 100. So we've got 100 here. So this is x minus 1994 squared. We're going to square root the left side and the right side. And when we square root this, remember this is plus and minus. So we end up with plus and minus 10 equals x minus 1994. We're going to add the 1994 over. So we get 1994 plus and minus 10 equals x. Now, we don't want to subtract 10 because that would be before our first data point, right? Which wouldn't make sense. So we're not going to actually subtract 10 here. We can ignore this subtracting part. We're just going to take 1994 plus 10, which gives you 2004 for x. So 2004, if we want to write this out, 2004, I'm going to slide up a little bit. In 2004, the budget was 630 million. Hope that makes sense.